Hi everybody, I wanted to talk about end behavior notation. So the idea is, in terms of end behavior, what that is referring to is when we're looking at our graphs, what's happening as x is going to positive infinity, and like what's the y values going to, like what's their end behavior, and as x is going to negative infinity, what are the y values going to. So we can see from for an even function that, and here's the notation, as x goes to infinity, we can say our y's go to positive infinity. So it's just saying what this reads, x goes to infinity, then y goes to infinity. So mathematicians are always like looking for that easy way to describe things, and so we use the arrow notation to say like what is it tending towards. So similarly, that was as x goes to positive infinity. What happens as x goes to negative infinity? But even from our discussion of even and odd functions, we should already know that this goes to positive infinity because of the symmetry over the y-axis. So what this is also showing us is that for any even degree polynomial, because even if this was like plus 5x squared minus 3x plus 1, for instance, and if you wanted to just type that in, what we would see is that the end behavior notation for this is going to be that as x goes to infinity, y is going to infinity. As x is going to negative infinity, y is going to infinity. And so even if our function was y equals negative x to the 6, then we need to know that as x goes to positive or negative infinity, y is going to negative infinity. So as x goes to positive infinity, y now goes to negative infinity, and as x goes to negative infinity, y goes to negative infinity. So we could have expected that as well, because we know from section 1.5 that the negative on the outside is going to flip the graph over the x-axis. Alright, so let's look at the odd function. So here's our odd functions, and so for when we look at its end behavior, we can see that as x goes to infinity, y goes to positive infinity, and as x goes to negative infinity, y goes to negative infinity. And so you can see that here. So as x is getting larger and larger and larger, all the y values are positive, and then on the other side, as x is getting more and more negative, all the y values are getting larger and negative values. And so similarly, if you were to change this polynomial to be like plus 9x to the 6 minus 5x to the 3rd plus 2x squared plus 5, and whatever it is, I know that because the leading term of this polynomial is has degree 7, that the end behavior is going to follow this. And so similarly, if we had y equals negative x to the 5th, we know that that's going to reflect the graph over the x-axis. So that means as x goes to positive infinity, y goes to negative infinity, and as x goes to negative infinity, y goes to positive infinity. So knowing this, it's going to be helpful to graph our polynomials, because in the end, we'll want to know which direction the polynomial is going. So I hope you found this helpful, and I'll see you in the next video.